Hello, my name is Sophie Specht and I'm from GEO in Kiel, Germany. I'm going to talk about tropical Atlantic variability in model and observation. Recent studies suggest that the intra-seasonal variability of sea surface temperature in the eastern tropical Atlantic is governed by tropical waves. These sea surface temperature variabilities have an impact on the development of the cold tongue in the Gulf of Guinea. This in turn has an impact on weather events in central Western Africa, like for example rainfall, and is therefore socially important. However, observations are too sparse to analyze tropical waves in detail. The recently launched Copernicus service CMEMS provides a new framework to study tropical waves. Therefore, in this study, our aim is to verify the ability of CMEMS to represent tropical waves. To do that, we compare the CMEMS model data with PIRATA mooring data. The PIRATA moorings are located along the equator as well as 0.7 degrees north and southward. For first results, we only used the moorings which are located at 10 degrees west. The moorings were first deployed in the mid-90s. Velocity data is only available after 2005 though. The CMEMS model is a reanalysis and forecast model which offers velocity data as well as temperature, salinity and sea surface height, with a high spatial grid of 1/12 of a degree and a temporal resolution of daily to hourly. It is available for roughly the last 2 decades. First, we analyze the zonal velocity. First of all, because this is convenient to analyze wave patterns, but also because zonal velocity is one of the parameters which is not assimilated in the model, and therefore it's good to verify that. Also, we did an analysis of velocity over depths to find the depths of maximum velocity and maximum variability. Furthermore, we also did spectral analysis. Firstly, when comparing the time series of the observation data and the model data, you can see that the observation is fairly sparse. Nevertheless, when comparing time periods where both data sets are available, you can see that the CMEMS model reproduces the observations fairly well. The most apparent velocity features which can be seen are first of all the strong eastward velocities of around 1 meter per second at a depth of around 50 to 100 meters, which show also a strong seasonal cycle. The velocities are highest in March and lowest in September. These high velocities are associated with the Equatorial Under Current. The CMEMS model also shows surface velocities which go in the opposite direction. The moorings can't resolve their surface. When looking at the velocity over depths, one can see that the velocities are highest on the equator and weakest north of the equator. We did our spectral analysis for the depths of the maximum velocity, so around 55 meters depths. Firstly, you can see that observations and model agree very well. Furthermore, you can see a peak between 11 days and 25 days. This is associated with tropical instability waves. We also did a spectral analysis of surface velocity data for the model data because the observations are not available. We did that because we thought that wave patterns would be more dominant at the surface. But different from expected, we couldn't see a dominant peak as we did before at 55 meters depth. Nevertheless, we saw some smaller peaks which are less dominant. Further investigations has to be done on the included wave patterns. In the future, we also want to include the other mooring locations in our analysis, and especially also analysis temperature, focusing on intra-seasonal variability. We also want to study the impact of tropical waves on dispersion processes in the upper ocean. So to conclude, we could confirm that the CMEMS model reproduces the observations very well and therefore provides a good framework to study tropical waves. The most important features we could find were the dominant impact of the Equatorial Undercurrent and the strong seasonal cycle, as well as the short time scale variability of around 11 to 25 days, which is associated with tropical instability waves. Thank you for listening.